This is GATE 2014 set 2 electrical question number 7. The switch shown in the circuit is kept at position 1 for a long duration. At t equal to 0 plus, the switch is moved to position 2. The value of V02 is greater than V01. The voltage Vc of t across the capacitor as a function of time is being asked. For NPTEL reference, you can refer to lecture number 15, Charging of Capacitor, Voltage, Current and Energy During Charging, of the NPTEL course Network Analysis by Professor Taposh Kumar Bhattacharya in Department of Electrical Engineering, IIT Kharagpur. The useful data you will need is the final value theorem for network, which gives the value of Vc of t as a function of time equal to Vc0 minus Vc infinity, where Vc0 is the initial value of capacitor voltage and this is the final value of capacitor voltage, into e to the power minus t by tau, tau being the time constant of the equivalent circuit or equivalent network, and plus Vc of infinity, that is the final value of capacitor voltage. Voltage across capacitor cannot change instantaneously. This information is useful, which implies that Vc at just before t equal to 0, that is Vc0 minus, equal to the value of the capacitor at that moment, that is at t equal to 0, and is equal to at t equal to 0 plus voltage. So these three are equal. Now coming to the solution, in case 1, the switch was initially at position 1 for time t less than 0, that is t equal to 0 minus. Now we are considering just before that instance the switch was at this position. So redrawing the equivalent circuit, this should be V01 connected with R and this is C, and the voltage is built up across the capacitor. So now Vc0 equal to V01, because this was at for a long time connected like this, so all this voltage appears across the capacitor, and capacitor connected with a DC voltage source acts like an open circuit with the voltage equal to the DC voltage source. At for a long time it is connected, that's why it is like this. Now for Vc0 minus, this is V01, so Vc0 is also V01 and Vc0 plus is also V01. Since Vc0 minus should be equal to Vc0, should be equal to Vc0 plus. Now at t equal to 0 plus, this voltage we know initial voltage should be Vc0 plus, which is equal to V01. Now capacitor with initial voltage can be modeled as a ideal voltage source in series with the capacitor with no charge or no voltage appearing across it. So redrawing the equivalent circuit, should be V02 and then R connected with another R and then in series with, now this charge polarity should be like this because the Vc0 should be charged like this. So the initial voltage across this capacitor is V01, which will be modeled as a DC voltage source V01 in series with the capacitor. Now this voltage source V02 is having a polarity like this, plus and minus. Now for t equal to 0 plus, the circuit can be modeled like this. At t tending to infinity, the equivalent circuit is like this: two resistors and then capacitor, and the initial voltage across the capacitor was V01. This V02 is greater than V01 in magnitude, so finally this capacitor will be open circuited and Vc infinity will be equal to V02 but with a minus sign, since this is like the polarity. So now the final voltage V is minus V02 plus, so applying the formula Vc0 Vc infinity plus Vc0 minus Vc infinity e to the power minus t by tau, where tau is 2R C, because this is R plus R, so 2R and C. Now this is equal to Vc infinity minus V02 plus V01 minus plus V02 e to the power minus t by tau. Now solving this as per get answer key, this is correct option, but if you solve it, it is v02 minus v01 plus v01 plus v02 minus v01 e to the power minus t by 2rc. It is v02 plus v01 minus v02 e to the power minus t by 2rc. The v02 and signs will be reversed. v02 will become minus v0 is considered in the right way, then it should be minus v02 plus v01 minus v02 or minus minus plus v02 e to the power minus t by 2rc. So this is the actually correct answer considering the correct polarity of v02, but in get answer key they have considered the opposite polarity of v02, hence this form is coming.